Welcome to the second episode of Our Place in Space, presented by the Astronomical Universe. In this series, we will discover our place in the cosmos and maybe learn just a little bit more about it. Today, we will talk about a star that's very close to Earth, only about 93 million miles away. This star is our Sun. Our Sun is a main sequence yellow dwarf middle-aged star that formed between 4.5 and 4.7 billion years ago. This means that it lies in the main sequence, or that diagonal stripe going from the top left of the graph to the bottom right. This graph is called the Hertzsprung-Russell diagram after its creators. Our Sun is a G-type star, which means that it has a relatively cool temperature of about 5,000 Kelvin, or more precisely 5,778 Kelvin, or for those of us who live in the United States and choose to use the stupid Fahrenheit scale, 9,940 degrees Fahrenheit. Our Sun is very cool when compared to O-type stars, which can reach temperatures of over 30,000 Kelvin, or over 53,540 degrees Fahrenheit. Even though our Sun is relatively cool when compared to other stars, I still would not want to take a nap on it, or even get very close to it for that matter. Our Sun has many layers, much like the Earth. The outermost layer is called the photosphere. That would be the layer that you would see if you looked directly at the Sun. I don't recommend that, by the way. Once photons, which are light particles, leave the photosphere, it takes about 8 minutes to reach the surface of the Earth. So next time you notice the Sun, you are seeing it as it was 8 minutes ago, or you are looking 8 minutes into the past. Now, before you go and stare at the Sun, Never look directly at the Sun because it can easily blind you. In fact, rumor has it that Galileo himself went blind when he tried to look at the Sun through his telescope. The next layer down is called the chromosphere. The chromosphere is usually never seen because it is drowned out by the light emitted from the photosphere. There is one time though when the chromosphere may be seen, during a total solar eclipse. Another layer down, you reach the convective zone. It is named for the process that goes on inside of it. Convection. And yes, this is the same convection that is going on in the Earth right beneath our feet, except with plasma rather than molten rock. After the convective zone comes the radiative zone. The name radiative zone is similar to the name of the convective zone in that they both thoroughly describe what is going on inside of them. The radiative zone radiates heat from the center of the Sun out to the convective zone. The next and final layer down is the extremely hot core of the Sun. Inside of the core there are millions of nuclear explosions going on all the time. Nuclear fusion is what takes place in the core. Nuclear fusion is when atoms are moving around so fast that their nuclei collide and result in a nuclear explosion, releasing heat and light. The hydrogen atoms inside of the Sun collide with each other and fuse to form a helium atom. Every second, the Sun fuses about 620 metric tons of hydrogen into helium. Have you ever looked at an image of the Sun and noticed a dozen or so black, dark-looking spots on the surface? Well, those are called sunspots, and they're not actually black. They just appear that way because they are cooler than their surroundings. The sunspots follow an 11-year cycle known as the solar cycle or sunspot cycle. Halfway through this cycle, the Sun reaches a point called solar maximum, when we see many more sunspots than usual. Then, after that, we reach solar minimum, in which there are far less sunspots than usual. During the solar maximum, we also see many more solar flares than usual. The most recent solar maximum occurred in 2014, so now we are on a slow decline. There is another type of solar weather called a coronal mass ejection, or a CME for short. These are high energy outbursts from the corona, the very outermost layer of the Sun, only visible during a solar eclipse because the light from the Sun and the photosphere drowns out the corona. Near the solar maximum, the Sun produces about 3 CMEs every day. Sometimes, when the Sun releases a strong coronal mass ejection towards the Earth, it has the possibility of cutting off power to large portions of the Earth by wiping out power grids across the world. One astronomical unit, or 1 AU for short, is 1 times the distance between the Earth and the Sun, or about 93 million miles. The Sun also emits something other than light and heat. It is called solar wind. Solar wind is a constant stream of millions of charged particles. These particles extend out over 100 astronomical units. And very few man-made objects have gone out past that, or past the heliosphere. These spacecraft, the only spacecraft that have ever traveled past there, are Voyager 1 and Voyager 2. The Voyager spacecraft were launched in 1977 by NASA itself. Their mission was to explore the outer solar system. Their mission was then extended to explore interstellar space. Voyager 1 entered interstellar space on August 25, 2012, and it will keep sending data back to us for a while. And then, the longest phase of the Voyager mission begins, to keep sailing into space, so that if any future civilizations find it, they might have an idea of where our home was, and they might have an idea of what we were. Each of the spacecraft carries a 12-inch phonograph record, which holds pictures and sounds of Earth. The record doubles as a time capsule and an interstellar message to any interstellar civilization. The record speaks to civilizations through the language of science. It shows the location of our solar system and then our planet. In 1990, the Voyager 1 spacecraft took one last look homeward and took the famous image titled Pale Blue Dot. You may have heard of it. This image was then famed by the famous astronomer Carl Sagan. He said, "Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam." Thank you for watching this episode of Our Place in Space, presented by the Astronomical Universe. In this series, we will zoom out from our home in space in order to better understand our place in it. And remember to give us a thumbs up if you enjoyed. And make sure to check out our website at www.astronomicaluniverse.blogspot.com. And tune in next time for the next episode of Our Place in Space. Until next time, clear skies and stay curious.